Electromagnetic induction. We have already seen that an electric current sets up a magnetic field. But many people wondered if the reverse of this is possible. In the year 1831, the British scientist Michael Faraday made one of the most significant contributions in the scientific world, as he succeeded in converting magnetism into electricity, hence discovering electromagnetic induction. Electromagnetic induction is defined as the phenomenon of inducing current by changing the magnetic field in a coil. Take a coil of wire. Connect a galvanometer with this wire. Now bring a magnet near the coil. You can see that the galvanometer starts deflecting. When the magnet is made stationary, the galvanometer shows zero deflection. Next, take the magnet away from the coil. Again we can see the deflection in the galvanometer, but now in the opposite direction. Again, when the magnet is made stationary, the galvanometer shows no deflection. In this experiment, just replace the first magnet with a stronger magnet. As we move this magnet towards the coil, we find that the galvanometer shows more deflection. So we can say that the current induced in electromagnetic induction depends upon the strength of the magnetic field. Now, keeping the first magnet, just increase the number of turns in the coil. As we move the magnet towards the coil, we can see that the galvanometer shows more deflection. Hence, we can say that the induced current also depends on the number of turns of the secondary coil. Once again, keeping the less number of turns in the coil and using the first magnet. If we increase the speed of the movement of the magnet, then also the galvanometer shows more deflection. So we can say that induced current also depends on the speed of movement of the magnet. Now take another wire and connect both the ends to a galvanometer. Bring a horseshoe magnet near the setup. If we move a part of this wire between the magnetic poles, then we can observe some deflection in the galvanometer. Hence, we have seen that electric current can be produced in a wire by simply moving a magnet in and out of it. From many such experiments, Faraday gave the following conclusions for electromagnetic induction. 1. The current is produced when the wire is moved relative to the magnet. 2. The current is produced when the magnet is moved relative to the coil. 3. No current flows when both the coil and the magnet are stationary with respect to one another. Reversing the direction of movement reverses the direction of the current. The magnitude of the current increases with the number of loops of the coil, the strength of the magnet, and the speed of movement. An electric generator, which is used to produce electricity, is the best example of machines that work on the principle of electromagnetic induction.